Hi, this is Dr. Balraju Karri, the author, Inorganic Chemistry, 4th edition of Cengage Journey. And today we are going to see the roadmap. It's a very special feature this year we have introduced in the just beginning of the book. This is Inorganic Part 2, where it begins with occurrence and extraction of metals. Metals chapter, metals exist in native state and combined state, right? And how these metals can be extracted by different means. That is next is metallurgical processes and reactions involved, where we see different processes involved, like starting from crushing to concentration, different methods of concentration for different ores, and then calcination, roasting to convert sulfide and carbonate ores to oxides, and then reduction of ores to metals, and then purification of the metals. All those things involved, and we go here on the road. Next step is thermodynamic feasibility in the metallurgy, where we see a Lingam diagram, and basically with respect to temperature, how the reaction will take place and which elements can reduce which metals. It's very important to understand who can be a good reducing agent at what temperature. And this is how we complete the first chapter and then go on to the next block chemistry, beginning with the P block. We ended the P block in the part 1 for the 11th standard in 13th and 14th group. 15th group onwards you will see in the part 2 in 12th standard, 15, 16, 17, 18. And the beginning in the P block, we are going to see here, different elements and the trends in the periodic properties, any exceptions in different groups, 15, 16, 17. And then we'll move on to the bonding and reactivity patterns, how they react, what kind of bonds they form, covalent bonds, ionic bonds. Of course, ionic is very difficult when it comes to P block because most of them are non-metals and metalloids, so they form covalent bonds and few can form ionic bond. And what kind of bonds they will have, what kind of reactivity they will be showing, all these elements. And we will move on to the oxidation states and redox behavior. Oxidation state is very important to understand, and they exhibit two types of oxidation states. Every group, lower and higher oxidation state. Down the group, how stability will increase or decrease and why it will happen, and what happens at the end of the group. Something called inert pair effect. What is this inert pair effect, and what will happen at different oxidation states, whether they will behave as oxidizing agents, reducing agents, or none of them. All these things you'll be seeing in this particular topic. And we move on to the structure and properties of compounds, whereon we see different compounds of P block, their structures connecting to chemical bonding of part 1, right? Very important. Like, giving example, if you see, talk about the basicity of hypophosphorus acid H3PO2. In general, for any acid, we say number of H plus ions it loses is the basicity, and whatever is for H2SO4, we say 2, HCl it is 1, H3PO4 it is 3. For H3PO2, we may think it is 3, but it is actually 1. That depends on the structure. When you know the structure of H3PO2, you understand that 2 hydrogens are attached to the phosphorus central metal atom, only 1 to the oxygen, and only the hydrogen atoms attached to oxygen can show the basicity, right? So all these structures are very important, and which structures are stable, which are unstable. Say some of the, say H3PO3 phosphorus acid is unstable, it gets disproportionated to phosphoric acid and phosphine. HNO2 decomposes to give HNO3 and NO. So all these reactions and structures we'll see over here. And then move on to oxides and oxoacids. Multiple oxides. So for nitrogen oxide, nitrogen shows NO, N2O, NO2, N2O4, N2O3, N2O5, out of which N2O3 is solid and it's blue solid, NO2 is a brown gas, and rest are colorless. Some are acidic, some are neutral, and so the variety of oxides these elements are going to show P block, and very interesting. You will see them, and also the oxoacids they show in the phosphorus. So 7 oxoacids. 7 oxoacids. You must have heard only about phosphorus and phosphoric acid. There are hypophosphorus, phosphorus, orthophosphorus, pyrophosphorus, hypophosphoric, pyrophosphoric, orthophosphoric, metaphosphoric, cyclometaphosphoric. Very interesting oxoacids, and questions based on the oxoacids are very interesting too. And these oxoacids, they will say more the number of pH bond directly hydrogen attached to phosphorus. More the number of pH bonds, more is the reducing property. When it comes to phosphorus oxoacids. Similarly, you have even sulfur shows oleum, Marshall acid. It doesn't know any martial arts kind of thing, but then it's called Marshall acid. So all these oxoacids we're going to learn here. Even fluorine can show HClO, HClO2, HClO3, HClO4 like this. And after learning all these oxoacids and the properties and the strength of oxoacids, more the number of oxygen atoms in the oxoacids, more is acidic behavior. You can say more is higher is oxidation state of central atom, more acidic character, and there is a comparison between them of different oxoacids. Then we'll move to the 18th group, that is noble gases, inert gases, rare earth gases. Generally we know noble gases do not react, inert. But एक गद्दार भी है, you know it, right? That is xenon. Xenon reacts. Noble gas react नहीं करते हैं, पर xenon react करता है. Why it reacts? What is, who is the people who are reacting with xenon? Oxygen and fluorine, who are the most electronegative atoms, their electronegativity dominates over the ionization enthalpy of the xenon. So how they react? When is the first noble gas compound was found? To know all this, you need to read this chapter, right? These all things we will read here, and then we move to the D block. After completing P block fully, we go to D block, that is transition metals. Now, all elements present in the D block are not called transition elements. Transition elements are supposed to have at least one unpaired electron. These people should have at least one unpaired electron in the D. But if you see, group number 12, zinc, cadmium, mercury, they have no unpaired electron either in their neutral state or in the ion state. Either cases they have no unpaired electron, they are not considered as transition metals, though they are present in the D block. This kind of interesting facts we will see in this particular topic, and their different properties, and they show variable oxidation states. Manganese shows +1, +2, +3, +4, +5, +6, 7, +7, right? Many oxidation states, and because of which they are used as a catalyst. They form many coordination compounds, and many other uses they found because of the variable oxidation states. All these things you will see in transition metal characteristics, and we'll move on to, in this chapter we get two gems. In the entire organic chemistry, we see two very powerful oxidizing agents, KMnO4 and K2Cr2O7, and they come from these transition metals, right? KMnO4, manganese, and then K2Cr2O7, chromium. Both are transition metal compounds. We'll talk about them, how we prepare them, what is the main ores from which we prepare these very useful compounds, and their properties, and how they do reactions in organic chemistry, and how they convert Fe2 plus to Fe3 plus, and many reactions like that you will see here. And we'll come down to the F block. In F block, it is inert transition elements, that is lanthanoids and actinoids. Then you have lanthanoid contraction, actinoid contraction, because of F and 4F and 5F series, they have very less screening, poor screening effect, right? And then you also study why the consequence of this lanthanoid contraction, how it is impacts the D block elements like zirconium and hafnium. They have similar size because of this. And these all some general properties, and 4F7 elements, 5F7 elements, like Europe ka gadha marries American Curie. That is europium, gadolinium, americium, and curium. They are 4F and 4F7, 5F7 elements. Like that, you have different elements important where you get the questions in the JEE mains and advanced. So all these things we'll see, and few more basic physical properties we're going to see here in this particular topic. And then we'll move on to the next very, very important chapter, and exclusive chapter called coordination compounds. They're really very different. They're the inorganic chemistry. All of the inorganic compounds are different. Coordination compounds are different. The word itself says coordination compounds. That means they have coordinate bonds. There is central metal atom, and there are surrounding atoms. All the surrounding atoms which are called as ligands over here. Some say ligands also. They form coordinate bonds with central metal atom. Why do these transition metals form coordinate bonds? Because they have no other option to get noble gas configuration. Now, how do they do that, and how they attain noble gas configuration? This is very interesting to know, and that's what is coordination compounds all about. And this topic of coordination chemistry, fundamentals, we see all those, what are the ligands, what different types of ligands, unidentate, bidentate, flexidentate, right? And ambidentate ligands, these kind of things. And what is the coordination number, primary valence, secondary valence, we will see over here. And as we move on, we also see in this complex compound how these complex compounds are named. Their nomenclature is a bit different than general inorganic compounds. With the nomenclature, we have isomerism topic also in this chapter. like organic compounds we see in GOC isomerism. Here also we have isomerism, structural isomerism, stereoisomerism. In that we see ionization isomerism, solvent isomerism, linkage isomerism, coordinate isomerism, geometrical isomerism and optical isomerism also present in this particular topic. And it's very interesting also to see there. And then you move on to the next last topic of this inorganic part 2 is a qualitative chemical analysis, where you basically you are going to see different group elements, group 1, group 2, group 3, group 4, group 5, group 6 and group 0 elements. They classify cations are classified like that. They ask questions on this topic, Ca2 plus belongs to which group, this kind of things. So how we identify them, their solubility and the redox reaction involved in it, and how we identify these elements, these ions, cations and anions in different compounds. All these things we are going to see here, which is more experimental chemistry, right? This is how we are going to move on the complete roadmap of inorganic part 2. Thank you very much.